Hi everyone, today I would like to share with you old testing equipment made by Heathkit. It's called Heathkit Precision multimeter. You can see it's from 70s, and this is the top cover. The plastic sort became yellow because of the time, and it's all metal made. You can see very good build quality, and even you see this connector from 70s. So this multimeter require 110 or 220 power supply in order to function. And let me see if I can move. So you see dial is very good. If you remove this, and of course, yeah, it's not that good. Red is lost the color definition, and you can see the Heath company, Benton Harbor. So yeah, this was a vacuum tube voltmeter. So basically you can check yeah, so this needle is moving because there is a little bit draft in the place I'm sitting in. So this is for the zero adjust. You can see you can adjust the zero, and this is the ohms adjustment, and you have alternating current off, AC, DC, DC plus, and ohms, and you have down common, and you have a DC and AC ohms, and you have all the different voltage rating, where you can measure not only within those voltage but also the value of the ohms. You can see, yeah. So nowadays multimeters are very tiny, and this is quite a bit chunky and old, of course. But in the tubes, vacuum tubes, you have a high voltage, and if you wanted to check the voltage on everything, then this was the good choice. And they call precision, and many of the electronic technicians, they have used this while repairing or calibrating their radios and other audio equipment which has a ohms high voltage tubes inside, and to measure the ohms rating on them. So I thought this is a very nice thing to share with you guys. So you can see in 70s what sort of testing equipment were used. And I have one more to show with you, and that one is a Samsung, oh sorry, it's a Siemens function generator. This is also from early 70s. Basically this is a signal generator. You have the frequency here, you have on off. You see everything is in German, and not only you generate AM, but you also generate the FM modulation, and you have the inputs, and here you have a DC, here you have a AC, and you have the frequency. You can choose up till 100 kilohertz, and this is a different sines waves you can choose on the when you do the modulation, when you mix the and make the carrier basically signal. This is the 5-volt signal, and this is the earth button, and this is the amplitude. So you adjust the amplitude. First you make the sine of the frequency, and then you adjust the amplitude. This is from the Germany made signal generator. These are important, especially when you troubleshoot a receiver stage and then you don't know where the signal is lost, and also for calibrating they are very good. So it has application on radio receivers and transmitters, any kind. It's also all made of the metal, you know, not plastic. 220 volt outside. Yeah. And yeah, it has a legs also. You can put it like that. I can show you how it looks like. Yeah. So this is another testing equipment in late 60s and early 70s were used in the labs also, and repairing technicians, engineers, they were using these kind of equipment. I have one more signal generator to share with you. So this is another signal generator, but this is made in UK, I think, or USA. Let me see. I think, as I remember, it's a UK company, Honor. Yeah. Oh no. Wow, what we find out? It's a made in Japan. I thought it was UK or USA. It's also a very solid built like tank, and you have the frequency here where you can generate the signal, and you have a band A, B, C, D, T till F. So, and all the bands are written here, and this one is the good one because this can create a frequencies up till 260 megahertz, which is impressive. And this is a RF attenuation, minimum, mid and maximum. This is audio frequency out, AF out, and you have audio frequency in, and the ground, external and internal you can choose. And yeah, so this is the RF out, this is ground, and modulation, and then you can feed into the oscillator circuit, and to see that where was the fault, and you take the faulty component out from the oscillator circuit, maybe, or in the IF circuit, but you can test every stage. Troubleshooting, these were the ideals. Also, you can do to feed the frequency whatever you wanted to check, especially for the calibration of transmitters and receivers. So because this generate very exact frequency, then you can penetrate it and also calibrate your equipment. So yeah, but nowadays we have a very tiny Chinese made signal generator. They have everything in built in. So but these were the equipment were used in the past. So this is from Japan, Honor. I thought this is either British or UK made. I mean UK or USA made, but it appears to be made in Japan. So very solid build. Thank you very much for watching, and I see you on the next one.